A new day, a new story. To determine how long it'll take to reach Mars, we must first know the distance between the two globes. Mars is the fourth Earth from the Sun, and the alternate closest to Earth. Venus is the closest. But the distance between Earth and Mars is constantly changing as they travel around the Sun. In proposition, the closest that Earth and Mars would approach each other would be when Mars is at its closest point to the Sun, perihelion, and Earth is at its furthest, aphelion. This would put the globes only 33.9 million long hauls, 54.6 million kilometers, piecemeal. Still, this has no way happened in recorded history. The closest recorded approach of the two globes passed in 2003 when they were only 34.8 million long hauls, 56 million kilometers, piecemeal. The two globes are furthest piecemeal when they're both at their furthest from the Sun, on contrary sides of the star. At this point, they can be 250 million long hauls, 401 million kilometers, piecemeal. The average distance between Earth and Mars is 140 million long hauls, 225 million kilometers. Light peregrination at roughly 186,282 long hauls per second, 299,792 kilometers per second. Thus, a light shining from the face of Mars would take the following quantum of time to reach Earth, or vice versa. Closest possible approach 182 seconds, or 3.03 twinkles. Closest recorded approach 187 seconds, or 3.11 twinkles. Furthest approach 1,342 seconds, or 22.4 twinkles. On average 751 seconds, or just over 12.5 twinkles. Light peregrination at roughly 186,282 long hauls per second, 299,792 kilometers per second. Thus, a light shining from the face of Mars would take the following quantum of time to reach Earth, or vice versa. Closest possible approach 182 seconds, or 3.03 twinkles. Closest recorded approach 187 seconds, or 3.11 twinkles. Furthest approach 1,342 seconds, or 22.4 twinkles. On average 751 seconds, or just over 12.5 twinkles. The fastest spacecraft is NASA's Parker Solar Probe, as it keeps breaking its own speed records as it moves near to the Sun. According to a NASA statement, opens in new tab, when the Parker Solar Probe comes within 4 million long hauls, 6.2 million kilometers, the solar face in December 2024, the spacecraft's speed will eclipse 430,000 long hauls per hour, 692,000 kilometers per hour. Closest possible approach 93 hours. Closest recorded approach 95 hours. Furthest approach 686 hours, 28.5 days. On average 384 hours, 16 days. The problem with the former computations is that they measure the distance between the two globes as a straight line. Traveling through the furthest end of Earth and Mars would involve a trip directly through the Sun, while spacecraft must of necessity move en route around the solar system star. Although this is not a problem for the closest approach, when the globes are on the same side of the Sun, another problem exists. The figures also assume that the two globes remain at a constant distance. That is, when an inquiry is launched from Earth. While the two globes are at the closest approach, Mars would remain the same distance down over the length of time it took the inquiry to travel. In reality, still, the globes are moving at different rates during their routeways. Masterminds must calculate the ideal routeways for transferring a spacecraft from Earth to Mars. Like throwing an outrage at a moving target from a moving vehicle, they must calculate where the Earth will be when the spacecraft arrives, not where it's when it leaves Earth. It's also not possible to travel as presto as you can conceivably go if your end is to ultimately circumvent your target Earth. Spacecraft need to arrive slow enough to be suitable to perform route insertion pushes and not just zip straight past their intended destination. The trip time to Mars also depends on the technological developments of propulsion systems. According to NASA Goddard Space Flight Center's website, the ideal lineup for a launch to Mars would get you to the Earth in roughly 9 months. The website quotes drugs professor Craig C. Patton, opens in new tab, of the University of California, San Diego. It takes the Earth 1 time to route the Sun, and it takes Mars about 1.9 times, say 2 times for easy computation, to route the Sun. The elliptical route which carries you from Earth to Mars is longer than Earth's route but shorter than Mars' route. Consequently, we can estimate the time it would take to complete this route by comprising the lengths of Earth's route and Mars' route. Thus, it would take about 1.5 times to complete the elliptical route. In the 9 months it takes to get to Mars, Mars moves a considerable distance around in its route, about 3/8 of the way around the Sun. You have to plan to make sure that by the time you reach the distance of Mars' route, Mars is where you need it to be. Virtually, this means that you can only begin your trip when Earth and Mars are duly lined up. This only happens every 26 months. That is, there's only one launch window every 26 months. The trip could be docked by using more energy, but Patton said that would not be the best use of current technology. Technology development may assist in docking the flight. The new idler for sending upcoming missions, and even humans, to the Red Earth will be NASA's Space Launch System, SLS. The SLS rocket is currently being built and tested, and NASA is now aiming for a launch of Artemis 1, the SLS rocket's first flight, in March or April 2022. In the future, robotic spacecraft might complete the journey in just 3 days. A spacecraft would use photon propulsion to calculate on a key ray to propel it to a speed that is close to the speed of light. Professor of Pharmaceuticals at the University of California, Santa Barbara, Philip Lubin and his squad are working on interstellar exploration using directed energy propulsion, deep in. According to him, the technique could send a 100-kilogram (222 pounds) robotic spacecraft to Mars in about 3 days. At the 2015 NASA Innovative Advanced Generalities (NIAC) Fall Council, Lubin stated, "There are recent advances which take this from wisdom fabrication to wisdom reality. There is no established reason why we cannot accomplish this." Thanks for watching. Don't forget to like and subscribe.